70% of the world's population actually lives off-grid. They're not connected to the power grid for various obvious reasons, such as geographical difficulties and also financial costs. And therefore, many nations have turned to renewable energy resources, such as PV, wind, and thermal solar devices to provide small villages and rural areas with the ability to have reliable energy sources, which is really essential for reduction of poverty and economic development. So this is today how a typical village energy system connected to a mini-grid looks like. It has renewable energy sources and non-renewable, meaning batteries and generators. Our challenge is really to create a smart grid to allow off-grid administrators to efficiently plan, allocate, and utilize the renewable and non-renewable energy resources. So today where we are is that the administrators are really blind. They don't know what's going on in the system on a real-time basis. There is no interaction. They cannot get forecasts, meteorological forecasts, and other really important elements that will provide them to have a better system. And where we want to get to is exactly those abilities. The ability to do all of these things, have an interaction between end users and administrators, and also have a variable pricing models, whereas today it's really a fixed pricing model. So, for example, we took, just as an example, an African village, and we will fly into this small African village in a while, and when we will actually get there, which is in a very few seconds, we will see how this village looks like. It has typically your type of like big users and a lot of group of small users. But what we typically have is about 10% of the users using 50% of the electricity, and the remainders use the rest of the information. So what is our solution in this type of situation? We will install energy meters with the largest consumers. And we will have the ability to do this forward planning of renewable energy generation. We will use meteorological systems feeding into the system. And we will also have energy profiling of the users, as well as having the ability to provide them with the prediction of what they're going to do 24 hours ahead. And the application will allow, using the phones, to have an interaction. So this is generally how it looks like. In orange, you have those measured using the meters, and those not measured using the fixed pricing model. So this, for example, is the village. You have, again, you see the public or measured, and those with the private with the fixed prices. Again, those in orange, just the important ones, for example, it may be the school, it may be those using water pumps, etc. So our system essentially will have a server located in the village. It will get the real-time information, interval data from the alternative power sources, as well as on the levels of the non-renewable sources, the generator, the batteries. It will get the weather forecast, interval data, and there will be an application, which I will touch on in a second, between the users and the administrators. It will feed into the relational database, which will also be locally placed, and then it will sync up to the utility servers in a remote location. So what are we talking about in terms of user interface and our proof of concept? So basically here, for example, you have the ability by the administrator to interact with that end user, saying, look, this is the maximum value of the power demand. These are the times, and what we recommend that you do in order to meet our energy level is to, for example, here shut down a second floor in your premises, and thereby will deduct from your electricity bill a certain amount. We're moving from the fixed price electricity bill to a variable electricity bill that will make it better, have a better responding and interactive system. At the same token, we can also have a predictive consumption from the end user to the administrator, saying, look, tomorrow what I'm going to use between these and these hours, I'm not going to use, for example, the pump or what have you, and thereby I can better plan the system going forward. And then if we go back, we can have the end user just simply pressing accept or decline and saving on their electricity bill, or just decide to decline, which is also fine. I mean, we're not forcing them to do it. So our business model is really targeting actually the utilities operators. We're not targeting the end consumers. We're telling the utilities operators, look, this is the way for you to have better micro off-grid networks. It will allow you to have savings in terms of the use of expensive non-renewable resources, because you will be better to be able to better manage your grid. You will be able to charge your end users, the largest off-grid consumers, on a non-fixed basis. You will have a better future system planning and energy demand understanding, also when you go in and install other systems in other places throughout the developing world. You have preventive maintenance because you have predictive power, because you have the ability to interact with your end clients. It's not just a blind system where you install and you leave. And of course, you also have a marketing edge, responsiveness, and reliability.